Hello everyone, welcome back to the channel. In the last class, we discussed about host path volume type in Kubernetes. To continuation of that, today we are going to discussing about very important volume type which is called persistent volume. So let's start with a simple situation. You deployed your application in Kubernetes, everything is working fine. Your pod is running, your container is writing some files, and your application looks healthy. One day, the pod crashes. What Kubernetes does is, Kubernetes always does is, it creates a new pod for you. Okay. At the first time, you are very happy because self-healing is working fine. But then you open your application and suddenly your data is missing. Now you start wondering, where did my data go? Okay. So the real problem here is why data is disappears. In the previous video, we used volumes like mtdir and host path. With the host path, we mount a folder from the worker node like /opt/conf into the container. So when the pod is running on worker node 1, everything is looks fine. Your data is written to /opt/conf on worker node 1. But Kubernetes does not promises that your pod will always run on the same worker node. When the pod is recreated, Kubernetes might place it on worker node 2 or worker node 3. Now your application again mounts /opt/conf, but this time it is /opt/conf on worker node 2, a completely different server or different work node with a completely different folder and completely different data because it is not on the same worker node 1, it is worker node 2. So from the application point of view, it looks like the data is disappeared. But in reality, the data is sitting still on worker node 1 and your pod has moved to worker node 2. This is the core problem in volumes. So this is where your data is tied to the particular server or particular worker node, but your pods are free to move between the worker nodes. And Kubernetes is doing the right thing by moving those parts. But coming to the storage part, our storage design is not ready for the movement. Okay, how you parts are moving between that servers, right? So same way, the storage does not moving between the worker nodes. So this is where the realization is we need storage that does not move with the pod. Now you think about the real applications like databases, user uploads, logs, and container configuration files. This data should not care which node the pods runs on, how many times the pod get restarted, or which container instance is currently alive. So we need a storage that stays or appears same data even when pods are deleted, or stays or appear the same when pods are moved between the nodes, and is should be independent of the pod lifecycle. Okay, so this is the moment where Kubernetes introduces a new idea, which is separate application lifecycle from the storage lifecycle. So that separation is the foundation of persistent volumes. So in real companies, the storage does not live inside Kubernetes. Your infrastructure already has block storage, NAS storage, and NFS storage. And if you can go to the cloud like AWS EBS volumes or Google disks, or we have some type of object storage and many more. Okay, so Kubernetes does not try to replace your storage system. Instead of Kubernetes says, give me a way to connect parts to real storage that already exists. Okay, so that connection is called as a persistent volume, which is called PV. A persistent volume is a piece of storage registered inside Kubernetes, which is backend by real storage outside the cluster. It is not inside the cluster. So this can be created at the cluster level. It is not node level or pod level. It is independent of any single pod. Okay. So once again, once the PV is exits, pod can come and go to that persistent volume and it will write the data, and nodes can change, doesn't matter. If pod can reschedule into any n number of node, the volume should be exist as it is, and the PVC exits as it is. So that is where here the data stored in a persistent volume lives beyond the pod life cycle. Okay, so this is the first big shift in thinking. Okay, so that is where pods are temporary, persistence volumes are long living. Now, this is where how developers use storage without knowing the infrastructure. Now, let's switch to the developer perspective. As a developer, you don't want to know which cloud disk is used, whether it is NFS or blob storage, or how storage is provisioned. You just want to say, I need storage, I need 10 GB, and I need read and write access for that. This is the request which is given by the developer. So this type of request we can call it as a persistent volume claim. So we already created that persistence volume from the cloud. The developer, he need to claim that storage based on his requirement by using PVC. So the simple PVC is a request for storage by the application, made by the developers, it made by the testers, or it made by the any engineer based on his requirement. So without worrying about the actual storage background, they can able to get the persistence volume storage by using PVC. So this is where now Kubernetes becomes the middleman. Kubernetes looks at the PVC and says, okay, which persistence volume can satisfy this request? If I say developer 1 requested 5 GB, so which persistence volume has that capacity? So for that moment, the pod uses the PVC. The PVC is connected to the PV, and the PV is backed by a real storage. So the pod never talks to the storage directly. The pod only talks to the PVC, and PVC talks to the PV. PV talk to the real storage, which is EBS volume or object storage, whatever it is. So this layering is what makes a Kubernetes storage flexible, and it is a powerful, and make sure it will be available at the cluster level. It is not for the object, it's not for the node level. Okay. Now everything is connected. Your pod starts on worker node 1, it mounts a PVC, and then that PVC is bound to a PV, and finally that PV is backed by a shared storage or cloud storage. Then finally your application writes the data. Okay. Now for some reasons the pod get crashed. Kubernetes recreates its on worker node 2. The pod again mounts the same PVC, then the PVC is still bound to the same PV, and then the PV is still pointing to the same real storage in the cloud, which is EBS or NFS, whatever it is. So even though the pod moved between the nodes or worker nodes, the data did not move. From the application point of view, nothing changed. The data is still available, or the data is still there. This is the exact problem we had with the host path and even MTDAR. So this is where this exact problems that PV and PVC will be resolved. Okay. Now you might wonder, who creates the persistent volumes? There are two common flows in some setups. The admin prepares the storage first and registers it in Kubernetes as a PV. Later on, developers create a PVCs to use that storage. This is called as static provisioning. In more advanced setups, developers only create the PVCs. Kubernetes automatically creates the storage and PV behind the scene. So this is called dynamic provisioning. The idea is simple here. You can either prepare the storage first or let Kubernetes create a storage for when you need it. If you created the storage first, then the developers will create a PVCs. That type of provisioning we can call it as a static. Or when the developers raise the PVCs, Kubernetes itself create the storage for when they requested. That type of provisioning we can call it as a dynamic provisioning. Let's see, when do you use actually the persistent volumes? Whenever your application has data that must be surveyed, whenever the parts restarted, where the parts rescheduling, or where node failures, rolling updates, all these cases, the persistent volumes can be useful. So that includes databases, user uploads, and even we have a logs, we have some backups. And if you use any stateful applications, all those things should be included. If you lose data, is not acceptable. If you don't use MTDA or hostPath, if you use PV and PVC, you cannot lose the data. Okay, so this is where PV and PVCs are very important, which is for cluster level. It is not for the node level, or it is not for the pod level. So in the next video, we are going to see how the PV can be created, and we will see that what is the static and dynamic, how we can create initially, and how Kubernetes will create dynamically based on the developer request. And we will see that live demos for PV and PVC. So this is about this video. Thanks for watching. So if this video is helpful, could you please comment and like and subscribe my channel.